This is the study guide for the radicals test for Algebra 1. So we'll go through these. This unit is obviously on square roots and cube roots. There are multiple ways to do them. I'll go through, I'll try to alternate left and back and forth, different ways to do them so you can see. Some ways are more efficient than others, but I'll try to go through all of them. Number 1 asks us to estimate to the nearest whole number. One of the ways you can certainly do this is find the square root that's closest to 40. Square root of 40 is right by a square root of 36, and it's also right by a square root of 49. Now it's really closer to 36 than it is to 49. Square root of 36 is 6, square root of 49 is 7. So 40 between those two is going to be between 6 and 7. So it would be closer to 6. So if I had to estimate to the nearest whole number, it would be 6. Same thing for 120. 120 is right by a square root of 121, and the square root of 100, which is between 10 and 11. Now it's much closer to 11 than 10. So let's say the nearest one is 11. The next one asks us to straight up simplify them. It requires you to know how to simplify radicals by the properties of radicals. Question C says the square root of 250. Me personally, you can either break it down into perfect squares, or you could do the prime factorization. I'll show you both ways for now. It doesn't matter which way you use, as long as you get it correct. So one way is to know your perfect squares. Know your perfect squares. And one way is the prime factorization way. Again, it doesn't matter as long as you do it correctly. Let's do the perfect squares way. There are many perfect squares in 250. One of them is 25, so 25 times 10. Square root of 25 is 5 times rad 10, and there are no more perfect squares than 10. If you know your perfect squares, it's a lot more efficient to do it that way. But if you didn't know it, you could still do the prime factorization. You might have realized 250 is 25 times 10. 25 is 5 times 5. Those are both primes. You could circle them. 10 is 2 times 5, not 5 times 5. 2 times 5 is 10. Now I have only primes circled. 2 is the only even prime. What you can then do is every time you see a pair of numbers, you write that down. The way to think of it is, if you have a date, you get to go to the dance, you get to leave, that's one pair. The guys that are left over, these solo individuals, have to stay home, 2 and 5, which multiplies to 5 rad 10. In either event, you get the same answer, 5 rad 10. D asks us to do the cube root of negative 27. Now the cube root is a little bit harder because it's looking for groups of 3. This is one that you probably should just have memorized for a perfect square or a perfect cube. The cube root, of 27 is 3, and the only way for it to be negative is for it to be a negative 3. A negative times a negative times a negative. 3 negatives. Since it's an odd number of negatives, these two make 9 times negative 3, which is negative 27. As you can see, negative 3's make negative 27. So the answer is negative 3 because they make negative 27. E is the type of example where I like to talk about sometimes people break up their radicals, they break it up the wrong way, and we have to put them back together. This is an example of sometimes you have to take one step backwards to take one step forward. So I can multiply radicals, it's one of the properties of them. If they're both into the radical, you can multiply them. If they're both outside the radical, you can multiply them. If one's in and one's out, you cannot do that. It's very similar to number L down here where the 2's on the outside. I can't multiply that because it's on the inside. All the inside stuff, though, the inside stuff I can do. Anyway, 9 and 4 is 36, stays in the radical. X squared stays x squared. Y stays y. You should break this up. Rad 36, rad x squared, and rad y. Square root of 36 is 6. Square root of x squared is x times x is x squared, that's x. Again, a pair of numbers. You can break this down also. X squared is x times x. Here's a pair, it goes on the outside. There's nothing left over to be on the inside. Here's a solo, stays by itself. 6x rad y for E. F is the square root of 216. You could do it by perfect squares, or again, you could do it by doing your prime factorization. Either way it works. Square root of 216, well, I gotta find a perfect square that goes into 216. I know 1 goes in, but it doesn't help us. The next perfect square is 4. I don't know if there's other things, but I know 4 goes into it. It's actually 4 times 54. Square root of 4 is 2. In 54, are there other perfect squares that go into it? Yeah, 1 goes into it, but 4 does not, 16 does not, 9 does not, 25 does not. We've reached halfway. There's nothing else that's going to go into it. So the answer is just 2 rad 54. Of course, you can also do the prime factorization way and break this down. Maybe you do 2 times 108, Susan prime. 108 is 2 times 54. Sorry, 54 is not a prime. 54 is 2 times 27, that's the prime. 27 is 3 times 9, 3 is a prime, and 9 is 3 times 3. So it looks like I actually missed one because 9 goes into this. So I'm glad I'm checking it doing this way because I missed that 9 goes into 54. I'll come back to this. 54 is 9 and 6, excuse me. So this is 2 times the square root of 9, which is 3 times rad 6, or 6 rad 6. Again, notice these are the outside, so you can multiply them. Glad I checked my work. Doing our prime factorization, as you can see, there are more pairs. 2 times 2, that's a pair, goes on the outside. 2 3s, that's a pair. I get 1 that goes on the outside. If you notice, there's some solo ones, a 2 and a 3 on the inside. 2 times 3 on the outside is 6. 2 times 3 on the inside is 6. 6 rad 6. Now you do have the opportunity to use a calculator for these, and you should use them for checking purposes. And here's what I mean. I know my original was square root of 216, so I could use second square root 216 and see what that decimal is, and then check my simplified version of 6 square root of 6 and see if it's the same thing. And since it is, that means I know that I simplified it. Did I know that I simplified it fully? Not necessarily, because remember I messed up and I got 2 rad 54. If I had 2 rad 54, you'll see it's still the same thing, but this is not simplified. So that's one thing you have to keep in mind and be careful of. I made that mistake. We could all make mistakes. Let's not make those mistakes on these tests. Try to move a little bit quicker. The cube root of 125 is just 5. That's just one you need to know. 5 times 5 times 5 is 125. Square root of 12p squared for h. Split the square root of 12. Square root of p squared. Square root of 12 is rad 4 rad 3, which is 2 rad 3. Square root of p squared, well, square root of p is p. P times p is p squared. Rearrange the order, send the radical to the end, it's 2p. Again, you could split it, 12p squared. P squared is easy, it's p and p. Again, a pair, that's by itself. 12 is 2 times 6, 2's a prime. 6 is 2 times 3. There's a pair of 2's goes on the outside, 1 solo, 3 on the inside, p on the outside. Again, rearrange the order, send the radical to the end. I is the cube root of 54, a to the 4th, b to the 6th. With these ones, the cube roots, you're not sure, my suggestion would be to do the prime factorization. 54 is 2 times 27. There are other ways to do it, but let's just do that. 27 is 3 times 9. 9 is 3 times 3. Come back to that. A to the 4th is, of course, 4 a's. B to the 6th is 1, 2, 3, 4, 5, 6 b's. The difference between square roots and cube roots is that square roots you're looking for pairs, 2, and cube roots you're looking for groups of 3. There are a triplet, 3 3's, that goes on the outside. 1 solo, 2 inside. Remember, it's the cube root. A triplet of 3's, a trio of 3's on the outside, 1a on the inside. Here's 1, 2 trios, so it's a b times b, which is of course b squared. Send the cube root stuff back at the end, which is 2 and an a, and I have 3a b squared, cube root of 2a. Not that hard if you take your time, split it up, look for triplets. Another example of what you certainly could do is put it all together and then split it up, but since we're going to do the prime factorization anyway, might as well just do the prime factorization. 14 is 2 times 7, both primes. 49 over here is 7 times 7. V to the 4th is 1, 2, 3, 4 v's. V is just a v. All right, every time we get a triplet, it goes to the outside. Looks like I have a triplet here, 7 and 2 other 7s. That's a triplet, 1 on the outside. The 2 goes back inside. There's a triplet of v's. That's 1 triplet. And there's 2 v's left over, which is not 2v. 2v's is, let me write that there. 2v's is v times v, or v squared. Putting the radical stuff together, 2v squared and 7v on the outside. Again, a triplet, 7 and 2 other 7s. One pair of these, this is one of these, and there's the cube root of 2 and 2v's on the inside, or v squared. I could do this one prime factorization, but I'm actually going to do it with perfect squares. There are many perfect squares that go into 48. 1 goes in, 4 goes in, but the best one is 16. 16 times 3. 16 times 3 is 48. Square root of 16 is 4. 4 rad 3, which is a simplified version. Again, you can use your calculator to check that part and verify that part. L has a 2 on the outside. A lot of students forget to multiply by 2 at the end. They forget to multiply by 2, and they lose points because they forget to do that. Let's do the prime factorization way, not that it really matters. 2 times this, what's the square root of 20? So I'm going to block this off because I'm going to do it later. I just want to remember to multiply by 2. 20 is 2 times 10, 2 is a prime. 10 is 2 times 5. As a pair of 2's, it goes on the outside, 1, 5 on the inside. Don't forget to bring down your times 2, which eventually makes 4 rad 5. All right, let's do the variables. X to the third is 3x, x times x times x. There's a pair, goes on the outside, 1 solo on the inside. Y to the fourth is y, which is 2 pairs, or y squared. Nothing left over on the inside. Z to the seventh, you're able to see how many pairs can I make from 7 z's. Well, I can make 6 pairs with 3 pairs that make 6 with 1 left over. 1, 2, 3 pairs with 1 guy left over. That goes under the radical. All the radical stuff goes back together. This is 4 rad 5, x rad x, y squared, z cubed rad z. All the radical stuff goes back together. 5xz. All the other stuff, 4xy squared z to the third power. Rad 5xz. You're essentially looking for pairs, which you're always looking for with all of these problems. I'll try doing this one a little bit differently. Remember that 4m gets multiplied at the end. Well, let me break 128 down to my perfect squares. I know 4 goes into it. 4 times 32? 4 times 32 would be 128. And then m to the 7th I know is m to the 6th, because that's an even amount, and 1m left over. Square root of m to the 6th is m to the 3rd rad m. It's 4m times square root of 4 is 2 rad 32. Now you got to remember, 32 is actually a perfect square also. 16 goes into that. So it's 4m times 2 times rad 16 times rad 2, m to the 3rd rad m. So you just got to be careful. It's not that big of a deal. This is now 4. 4m times 2 times 4 times rad 2, m to the 3rd rad to the m. Rad m. Now again, all the stuff on the outside can be multiplied. This is 4 times 2 is 8, times 4 is 32m to the 4th, because m times m to the 3rd is m to the 4th. So again, doing it slowly. 4 times 2 is 8, 8 times 4 is 32. M times m to the 3rd is m to the 4th. And the 2 and the m go back together in the end. Last one here on this page, square root of 24. I would do rad 4, rad 6. Square root of 4 is 2, 2 rad 6. Actually, a pretty easy one. I know my perfect squares go into that. Could have done prime factorization, but that one's easier to do it that way. 3, O, P, Q, and R asks us to rationalize the denominator. In order to rationalize the denominator, essentially what you have to do is make the denominator, which is the bottom, a rational number. This is easy. Square root of 25 is 5. Square root of 100 is 10, and 5 tenths becomes 1/2. There's a situation where I can't just do that because the square root of 6 is not a nice number, so what I'm going to have to do is the process called rationalize the denominator, which means I multiply by the exact same radical, rad 6. 16 times rad 6 is just 16 rad 6. Rad 6 times rad 6, any radical times itself is just what's called the radicand, the number underneath. And you would be done, except see how these are both on the outside, and it can be simplified by 2, which means it's 8 over 3, and the rad 6 stays. This cannot be simplified. Don't be tempted. 3 is on the outside, 6 on the inside. You can't simplify those. Q I'll do over here. 2 over rad x. Same idea though as p. Got to get rid of the denominator by multiplying by the exact same radical. 2 times rad x is 2 rad x. X times x is again x. It's just a number underneath. The reason is because square root of x times square root of x is square root of x times x is x squared, which is of course just an x. Same thing happened with the rad 6 times rad 6 is just 6. Again, this is done. No more simplifying that I can do. Let's do the last question. O looks like it's already split. If you see O, it's already split to two different things. This one has to be split. So I split it 4x squared over rad 3. You're allowed to split the radical top and bottom. Before I go too far, the top is actually simplified, is able to be simplified. Square root of 4 is 2. And the square root of x squared is x, but I still have that rad 3. Still got to rationalize the denominator. Multiply by the exact same denominator. 2x times rad 3 is 2x rad 3. And rad 3 times rad 3 is 3. No more simplifying I can do because the outside stuff can't be simplified any further. For question number 4, I'm going to show you two ways to do it. The way that you're supposed to do it and the way that can be done much easier. This is a tough question because you got to simplify square root of 135. You got to then simplify the square root of 675. You then got to simplify the square root of 45. And you got to square 2025. So you could do all of those things. But there's a back route way to go. So I could do the hard way of simplify, 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 simplify. There's the back root way, and there's an even easier way. Here's the back root way. Well, in order for 15 to have gone under the radical, that means it must have been a 15 and another 15. Two 15s would give me just one 15. Because 15 times 15, we already talked about this, the same number times itself as well on the outside. So this is really 2 radicals times itself. Well, if it's 2 radicals times itself, it's just 15 times 15 are 225 times rad 3. And 225 times rad 3 is, of course, 375, which would be, 675, which would be choice B. Of course, you also could have done this, and this is the semi-cheating way to do it. We have a calculator. And what we can do with this calculator is we know that when we're done, we want 15 rad 3. Let me turn it on first. We want 15 rad 3. That's what it says, 15 rad 3. What is 15 rad 3? It's 25.9807. That's not one of the choices because it's not going to be one of the choices. But what I can do is just square root all these guys. Square root of 135. Is it 25? No. Square root of 675? Ah, same thing. Let's just check the rest just to be sure. Square root of 45? Obviously too small. And the square root of 2025 is too big. That's what that is. The answer is, of course, choice B. 5 is a little bit harder because we got to do that same idea. Which one of these, when you took the square root of it, which one of these resulted in that? That's what that's asking, that's what that one's asking. So we really got to do that back root way because a lot of these would take too much time. So let's do the back root way. The 10CD stays. In order to get 6, it's rad 6 and another rad 6 because rad 6 times rad 6 is a 6 on the outside. To get c to the third, it's c to the third and another c to the third. And to get d, I'll do over here a d and another d. So let's put this all together. This is rad d squared, rad 36, rad c to the third times c to the third is c to the 6th, all times 10cd. Again, if it's under the radical, we can do this. 36 times 10 is square root of 360. C to the 6th and 1c is c to the 7th. And d squared times d is d to the third. So it's 360 c to the 7th, d to the third, which is choice D. Now you also could have eliminated some choices by just doing the 6, same way as we just cheated, by doing the 6 and the rad 10. Watch as I do the 6 and the rad 10. 6 square root rad 10 gives us 18.973. I could have just checked the second square root of 60, just the number part, so it's not A. Is it 360? Second square root of 360. Yep, that's the same, so it's either choice B or choice D. I know it's not square root of 600, second square root of 600, because that one's going to be too big. So it's either choice B or choice D, and we figured out that it is choice D. Make sure you use your calculator. Your calculator is a checking tool. It will allow you to check your work. It won't give you the final answer, but we'll allow you to check to see if you're on the right path. It's a tool. It's not the only way to get the answer. The calculator alone will not get you the answer.